Okay, Cappuccino, here comes our notes for today, Tuesday, April 21st, volume of revolution around the y-axis. So first of all, here's the formulas. This one is for the revolution around the x-axis. This is the one that is in your formula packet, except that on the formula packet it has the pi inside the integral. But since that's a constant, I just move it to the outside. I find that's a lot easier. And also, this x equals a and x equals b doesn't show up on the formula packet because on our formula packet, it's assuming we're only going to do revolutions around the x-axis. But if we're going to revolve around the y-axis, these numbers can represent values on the y-axis. So when we're revolving around the x-axis, our minimum and our maximum are going to come from values on the x-axis, but when we're revolving around the y-axis, they're going to come off of the x-axis. So I'll give you an example in our example here. So you are going to be doing 5 problems in math space, so make sure you are careful about whether they're asking you to revolve around the y-axis or the x-axis, because I mixed it up a little bit to keep you on your toes. So if you want it to be around the y-axis, we're going to be using this formula. And the problem, though, is that you're going to be given an equation that's not in the correct form. Okay, so we need to be a little bit more careful when we're doing it around the y-axis than around the x-axis. The x-axis is pretty straightforward. Okay, so first thing you should do, step 1, is sketch the graph. Whether that means put it into your graphing calculator to see how it looks like or actually graph it yourself. This one's pretty simple, so I'm going to go ahead and just graph it myself. So I'm going to see, well, what does this look like if I'm going y equals 2x from 0 to 9? Okay, so 0 to 9, I suppose I don't have to count by ones, but I'm going to. I'm going to go ahead and start down here, because it says starting at 0. So I know I'm going to start at y equals 0, and I'm going to end where y equals 9. So let's go ahead and graph this line. Y equals 2x is a line. The y-intercept is 0, and the slope is 2, so over 1 up 2. And I am going to be going up to where y is 9. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. So here is where y is equal to 9. So from 0 to 9. And then I'm going to go ahead and draw in my line until I hit 9. So this is the region that is going to get revolved around the y-axis. So here's the y-axis. So this is going to get revolved around the y-axis. So if you imagine taking this triangle and rotating it around the y-axis, if you were to rotate it 360 degrees around that and made a 3-dimensional object, you would have a cone. So it is actually possible to just look up what is the formula for the volume of a cone, and you could just do that. But we're going to use calculus. So step 1 is to make a sketch. And this is important for some of the problems in math space because they're not going to give you these numbers where you're going to start and stop. You have to figure that out by seeing where does the curve cross the y-axis. Okay, so you might have to look for those y-intercepts. In this case, it's pretty straightforward because they give you the y values that you're going to use. But step 1, sketch it. You want to make sure you know where your y-intercepts are in case they don't tell you what the parameters are. What's your minimum and your maximum? Okay, so there's step 1. Okay, step 2 is step 2 is that we need to solve this equation in terms of x. Okay, so we're going to solve y equals 2x in terms of x. So that means we're basically just going to take this and we're going to solve it for x. So our equation is going to say x equals. So right now we have y equals 2x. I want to get the x by itself, so I'm going to divide both sides by 2. So I get x is equal to y over 2. Okay, so there is our equation that is then going to go in here. See how it says x squared? So we're going to be taking this, y over 2, and we're going to be putting it in right here. Okay, so step 3 is we're going to set up our integral. So I need to turn the page. Sorry about that. I should have done this whole thing on one page. So step 3, set up the integral. Okay, so my integral, it's going to be pi, and my parameters are going to be y equals 0 up to y equals 9. And then it's x squared dy. Well, what is x squared? X squared is, well, x is y over 2, so it's going to be y over 2 squared dy. Okay, so this now we're going to use our same integration techniques that we would do if this had been x squared and this had been dx. So it doesn't matter what letter it is, we're going to use our same integration techniques. So in math space, it's going to say solve by methods of disks. That's the same thing. Okay, so this is methods of disks. Okay, integrating is the same thing as methods of disks. Okay, so step 4, we're going to solve it. Solve the integral. So on MathSpace, it's going to be asking for an exact solution. So you're not going to be able to actually do it on your calculator because of the pi. That's going to, if you do it on your calculator and you multiply out by pi, you're not going to get an exact solution. So, but you can definitely check your answers on your calculator, okay? So go ahead and you could put this in right now. You could put that into your calculator, just changing the y to an x when you put it in. Okay, so let me just show that real quick. So if you go to, we go in here, we want to enter it in. This would be parentheses x divided by 2 because there's no y variable when we're entering in a graph, squared. So you could do that and graph it and then integrate it from 0 to 9. Okay, so you could do that in order to check it, and then multiply your answer by pi and to check it. But we're going to do it by hand. All right, so we're going to integrate this. First of all, I'm going to multiply this out rather than using the chain rule. I think it's going to be easiest if I just multiply this out. So I've got my pi from 0 to 9 of y squared over 2 times 2 is 4. Now I have this constant, this over 4. I'm going to move that out to the side. So I'm going to move it out here, that divide by 4. So I'm going to have, oh, this is volume equals, sorry, forgot my v. So I'm going to have volume equals pi over 4, integrate 0 to 9 of y squared. So now if I integrate y squared, that's going to give me, I can still have my pi over 4, and that's going to give me y to the third over 3. Oops, that looks ugly. Let's try that again. Y cubed over 3, just our typical integration, and that's going to get evaluated from 0 to 9. Okay, so now I'm going to do my evaluation. I still have my pi over 4, and then I'm going to evaluate all this. Y to the third is going to be 9 to the third divided by 3 minus 9 to the third, sorry, 0 to the third, 0 to the third divided by 3. All right, this one's obviously just 0, so that one goes away. So pi over 4, 9 to the third. Here's where I'm going to grab my calculator. I don't know, what is that? So 9 to the third power is 729. So I have 729 over 3 minus 0. So that's just 729 over 3. And 729 divided by 3, that can be reduced. 729 divided by 3 is 243. And I'm starting to think I made a mistake somewhere because that's not the answer I got before. What did I do? Pi over 4, I did the third, divided by 3, 729. Oh no, I think that's right. Okay, and so if I 243 cannot be divided by 4, so I just get 243 pi over 4. All right, now if I want to check that on my calculator, I'm going to go back to that y equals. Okay, so that was this. And now I'm going to graph it. and I'm going to use my integral, and I'm going to say from 0 up to 9. Okay, and so it would be 60.75 times pi, right? Because then I have to times it. Oops, where is it? Then I have to times it by pi. So 60.75 times pi is 190.8. Is that the same as this? Fingers crossed. Yes. Ding, 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 ding. So I checked it with my calculator, but for math space, it wants an exact answer, so it's going to be this, and that would be units cubed, because we're talking about volume. So there's my final answer. Okay, so your problems in math space are all really similar to this. There's one tricky one where the sketch is going to help you, okay, because you're going to need to figure out what are the lower, upper, and lower boundaries by looking at the sketch. All right, good luck. And we will have office hours tomorrow on Wednesday at 10:30. And I'm going to shorten the office hours because not very many people have been showing up. So we're going to go from 10:30 to 11. And then we'll do that again on Friday, 10:20 to 11. We'll have longer office hours on Friday. All right, bye-bye.